back, or I must say, welcome back, Melvin and Jarno. uh, we had some problems, some technical issues, as we already told you about everything that we planned, but yeah, the demo god's not in my favor today. But yeah, we will skip the structured exception ender part. I will try it the next TeamUp session. I will make a backup plan for next time, so in case it happens again, at least I will have a backup plan, as I did not have today. But yeah, we just go to the second part of the stream. That will be Wireshark. As you can see on the screen, it is the box Carnage. So I will hand it over to Jarno Baselier. So enjoy and have fun.
Thank you very much. Yes, like I asked on my Discord channel, what will we be doing today? And we would the most votes were for Wireshark. So yeah, let's work for Wireshark. And I was thinking about what can I show within Wireshark. I do not want it to be an educational session in the sense of just showing Wireshark and in theory what we can do with it. I want to show it in real life. So today I will be working from a blue team perspective with Wireshark and maybe some other tools to dissect and analyze some network traffic. We will be using the Carnage room like you're seeing on screen from TryHackMe, which is a medium rated room. So if you want to follow along, please let me know and I'll wait a little bit while you spin up your machine. I already spun out mine and it's running for like 1 hour and 26 minutes now. Wireshark is great. It's an open source tool for analyzing network traffic. Wireshark can intercept traffic in real time and store this data in special packets called PCAP files. These PCAP files enable you to search and analyze the traffic later on. In addition to PCAP, Wireshark can handle many other formats, and the latest PCAP format is PCAP Next Generation or PCAP NG, but legacy formats such as CAP and dump are also still supported. Wireshark, for a little background, is the successor of Fork of the well-known Etherreal and is available for free for all operating systems. With Wireshark, you can analyze network packets. So as a researcher, we can figure out what kind of traffic is sent and received. The Wireshark functionalities are closely related to applications such as TCP dump and of course previously mentioned Etherreal. The big upselling point is that Wireshark offers a unique GUI that makes it easy to use. Etherreal was developed by Gerald Combs, I guess, well, something like that, and released in 1989. Gerald changed his job in 2006 and was not allowed to carry the Etherreal brand name anymore. So with his knowledge and the source code from Etherreal, he started on developing Wireshark. There's also a terminal-based Wireshark version called T-Shark, and T-Shark is installed automatically while installing Wireshark. Wireshark processes the packets addressed to it by default, but you can set your NIC or your network card in promiscuous mode. Then Wireshark will allow you to intercept all packets handled by the network interface. And this is because the network card in promiscuous mode will accept all frames, allowing Wireshark to intercept and log them. Wireshark will try to place the network interface in promiscuous mode during startup. However, it is not possible to enable promiscuous mode with every network card. The Wireshark page allows us to download Wireshark and it offers a ton of information and videos. We can take a little look at that. Wireshark. And we can get acquainted with Wireshark. Of course, we can download Wireshark with many different formats available for us. We have a few resources like frequently asked questions, a Q&A, but what I'm searching for is like the user guide, command line manual pages, like a lot of information available from the website itself. And Wireshark is installed by default on Kali Linux, of course. So I guess that's enough introduction. And my instance is started, so that's okay. I have not done this box before, so, well, yeah. I'll be looking at this traffic for the first time. I was too busy to prepare well, so let's pray the demo gods will be in for a safe ride for me. First, let's see, because we started the box, I've started the machine, and I guess we do not have the ability to download the PCAP file, but we have to work with the machine that is provided. As a background, Eric Fisher from the purchasing department at Bertel Limited has received an email from a known contact with a Word document attached. Upon opening the document, he accidentally clicked on Enable Content. The SOC department immediately received an alert from the endpoint agent that Eric's workstation was making suspicious connections outbound. The PCAP was retrieved from the network sensor and handed to you for analysis. So it's up to us to analyze this PCAP file. Read the above, we have done that, so that's okay. And there we have all the questions for us we need to try to answer. But before we can answer them, let's show the split view, opening up the remote machine. And here we have Wireshark, of course we do. And I'm wondering if my double click was okay and it's just slow, or I need to click it again. Let's click it again. And oh, wow, there it is. This is Wireshark. Oh, well, now it's booted twice. We do not need it like that. So let's just, oh, this is Wireshark. Nope. Analysis, I guess. Yes. And here we have the Carnage PCAP file. Let's drag it in Wireshark so we can take a look at traffic. And our first question is, what was the date and time for the first HTTP connection to the malicious IP? Well, the malicious IP, do we know the malicious IP? I guess it was not, they didn't tell us, right, what it was? Nope. Okay, so we have to figure it out ourselves. The first HTTP connection to the malicious IP, let me see if I can enlarge this. Yes. Right, the first thing we are going to do is just filter on HTTP, because, well, they're asking us for HTTP packets. And down here we have the time column. And one thing I always like to do is to edit my columns. Oh, not like this, which is fine. Column preferences, I guess. Let's add a new column and let's call it source port. And link this to destination address, source port, like this. And we do the same thing for destination port. And like this. So we have a little bit more information on the ports it communicated with. And let's take a look at the timestamp itself. We can. Where the most top one is the most recent one, I guess. Let me change the view to simply show the time of day, seconds, UTC. Well, what do we choose? Second since, that's not what we want. I'll just choose date and time. It's all from 2021. And this is the first HTTP packet that was captured. But what is the malicious IP? Maybe we can use the statistics to find it. Let's look at some IPv4 statistics. And we have an IP with which we see a lot of times, 822 times, but let's filter on the count. And I think this one stands out, 10.9.23.102. This one is referenced a lot of the times. And it's in the first HTTP packet. So I guess we are going to use this date and time. Let's try if it works. I guess it should be. How do I exit full screen? Oh, well, like this. And we will answer it like 2021 09 24 16 44 and then 38. Whoop, whoop. And this answer is correct. So we know malicious IP is probably 10.9.23.102. Second question is, what is the name of the zip file that was downloaded? So probably a zip file is downloaded. An easy way to find it is to go to File and export objects from HTTP. And it will find a lot of the objects within the HTTP stream, and one of the objects it found was documents.zip. So I think this is our answer. That was quick. What was the domain hosting the malicious zip file? That's a good question. Let's go back to HTTP. And can I look at the packet? I cannot. Packet 2173. So that is this packet. And now let's take a look at the data inside. The TCP protocol with a source and a destination port, but we need the IP protocol. We do have some IP addresses, but they ask me the domain name. So I'm wondering if we are resolving at the moment. Name resolution. We also want name resolution for the network addresses. And now we can see it at the source. This is at whatever.com. Right. Let's try this one. HTTP ironepal.com. And this one is correct as well. Without downloading the file, what is the name of the file within the zip file itself? How will we do this? Because when I can only save this document, and we cannot check the files within the zip file from the packet perspective, at least I guess not. Maybe we can follow the TCP stream. And let's see what we can find in here. I don't know if this is the file, but it at least has an extension of XLS UT, whatever that is. Let me simply copy this. I have my doubts that I can copy paste. Oh, well, it does work. Let me see. It needs an extension of 3 letters, so let's remove the UT. Well, look at that, it's correct. Okay, so this is indeed the file name within the zip file. And we can find it because we are looking at the TCP stream. And well, we can basically look at every bit that passed the wire within the communication for this package. What is the name of the web server of the malicious IP from which the zip file was downloaded? What was the name of the web server from the malicious IP from which the zip file was downloaded? The name of the web server. Okay. Let me again look at the TCP stream. Oh, well, enlarge. I'll have my. Is this the same stream? I guess it is. This. I think if we are looking for the name of the web server, we should be looking at the header. Source is from a desktop to going fortune, destination. Compute internal. Destination. Let me again follow the stream. And let's see what we get from there. From this one we already found. You know, the file name. Oh, wow. There it is. That's the web server, Lightspeed. At least, I guess it is. So let's submit, and yes, this is correct. What is the version of the web server from the previous question? The version of the web server must be in the header as well. It's probably this one, PHP 7.2.34. And that's correct as well. Malicious files were downloaded to the victim host from multiple domains. What were the 3 domains involved within this activity? Malicious files were downloaded to the victim host from multiple domains. So we first need to figure out what files were downloaded, right? Before we can find the 3 domains that were involved. Let me check the hint. Check HTTP traffic narrowed down the time frame from 1645.11 to 1645.30. So that's a very narrow time frame. Okay. Let's close this up. Let me take a look at the statistics. HTTP, and then the requests. And here we do have a few hosts that were used, like 3 and some weird ones. Let's use the statistics and go to the conversations. There you are. So we can take a look at the traffic that went from A to B and back, which host had a conversation with each other. We need a TCP stream for this. And simply let's try to filter on the packets. And here we have a few of those packets transferred over port 443. 104.38. Do we have a notepad or something? I think we do. Let me grab this IP 104.83.84.137. Many packets were sent from this address over port 443. So let's filter on this IP, and we will use the filter IP address. And we also want to make sure that we are only seeing the traffic from port 443 HTTPS. So we will do a double N sign, and TCP port is equal to 443. So this is all traffic from that IP address. And the hint, let me check the hint again, also gave us the option to use a time frame of 19 seconds. Let's do this as well. 19 seconds. It will, I thought this was something with frame time. Frame.time, yeah, that's the thing. And we want the time to be larger or equal than September 24, 2021. And it was 16:45:11, like this. And also, our fourth filter will be the frame time. And it will be equal or smaller than September 24th, 2021. And then 16:45 and 30, I guess it was. Or not. Let me see. We have September the 24th, 2021. Let me remove the last one and see if this returns something. This does. Did I make a mistake? Let's just simply copy paste, make this a smaller sign and change this one to 30. And it still doesn't show anything. It was 45:30, right? Oh, not that one, this one. 16:45:30, yes, that's correct. Then let's just remove this one. And take a look at what we see here. We see source coming from the desktop, and it travels to an external location over port 443. So this is probably the desktop that was hit, that we are analyzing right now. So let me filter on that as well. IP.src host was it? Yes, that's a thing. And this one is equal to desktop dash iojc 6 rp dot goingfortune.com. Okay, and what do we see here as a destination? Do we see anything that's interesting in the destination? It all goes to Akamai Edge. So that is not that interesting. What do we see? I am very troubled with this question. How do we do these things? Let me see. We have an address that's correct. We want HTTPS. We do have the time frame of the frames, 24th of September, and we do have you mean like the hint? Yeah, the hint is pretty vague. Check HTTPS traffic. That's what we're doing, and narrow down the time frame from 1645. That's what we're doing as well. So within this traffic, I guess we should find 3 domain names to where files were downloaded. Malicious files were downloaded to the victim host from multiple domains. Yeah, and we want to know the domains that were involved within this action. But now we do have a source of the desktop. I think we need maybe the desktop was a destination, right? It was not a source. Let me see if we work the other way around. And we still have akamaiedge.net, and I was hoping we would see 3 different domains. But we do not. This IP address. Let me remove that as well. I'm not sure if that's the correct one. And let me try again to narrow down the time frame. Like this, and then it's again smaller than 30. Let's see what we have now. At least we do have some domain names, right? We have findjewels.com, and we have T@BACT and New American Code. And if we look at the format we need to supply, we have 3 stars and 2 stars. This means we have an extension divided by 2 and 3, and this is 3 and that's 3. This can be the answer we are looking for. So again, let's try. Let's try findjewels.com. And we also had this one, THIAT. Come on, what a name. .com. And we have this one. And this one is the New American Code.com. And then again, if we look at the format, we need to supply the answers. We first get this one. then yeah, and we have to divide them by a comma. So like this. This should be the answer. Fingers crossed. And it worked. Cool. Okay, which certificate authority issued the SSL certificate to the first domain from the previous question? And the first domain is findjewels.com. And which certificate authority issued the certificate? Let's go to the findjewels.com and let's follow the TCP stream again. And let's see if we can find. Oh, I think I'm already seeing it. It's search.godaddy.com. So close this one up. And I think the format is not correct. I think it just needs GoDaddy. Yes, it does. What are the two IP addresses of the Cobalt Strike servers? Use VirusTotal, the community tab, to confirm if IPs are identified as Cobalt Strike C2 servers. Answer format, enter the IP addresses in sequential order. Yeah, okay. I think the first thing we need to know is the kind of traffic that Cobalt Strike is using. Is it using HTTP, HTTPS, DNS? Check the conversions menu option. Okay. Let's go to the statistics, conversations. And what am I looking at? What are the two IP addresses of the Cobalt Strike servers? But there are probably many IP addresses, right? Yeah, there are so many IP addresses. We cannot check them all against VirusTotal. That's not doable. Let's disable network resolution because they are asking me for IP addresses. So like this. Let me try something. Let's go to the TCP tab. And we can copy this as a comma separated value file. And then what can we do then? Let's paste this one in Sublime. Hello. In Sublime Text. I only need the address column. Let me copy paste this to Microsoft Excel for a second. I want to paste it like this. And I want to split it to columns. I want to separate them by a comma, like this. And the address column. Okay, well, it's a long shot. So these are our addresses from which we have communicated. Let's try to use a regex like this. Matching the first 3 octets of the IP address. And we are not sure this is correct. We can do this because, but now we are cheating a little bit. Oh my God. Because we know that the last address they are asking us do have 3 stars, 3 stars, 3 stars, 3 stars. So it's an address that has like 12 digits. And we can also do the same thing for the first address, which has 332 3 stars or digits. Well, but this has no methodology. This is just cheating on finding the right answer now. If you have a better idea of finding Cobalt Strike servers, please let me know, because I have no clue what IP addresses were used as the Cobalt Strike servers. And we cannot enter every IP address at VirusTotal to check if it is a possible Cobalt Strike server IP. I think in real life you should do that, right? In real life, you do have a packet dump, and you do have a lot of IP addresses, and you want to know which one are malicious, and so you are going to check them all, because you cannot know by head which one is malicious and which is not. For now, I will continue with cheating a little bit. Let me check. Well, this is what we need to match. Let me see what IP addresses I do see a lot. 248, 174, all 174. So it looks like 174 has generated a lot of traffic. Again, 174. Let me just take a wild guess that this is the first IP address I am searching. And now for the second one, we want to match another pattern like this, and then again like this. So now we are looking for every IP address that has 3, 3, 2, and 3 digits. And let's see if we can find something that is used a lot. Ending at 158, again ending at 158. A lot is ending in 150, I think they all are. Yeah, so let me guess that this one is the second one we are searching. Again, it might be a bit of cheating, but maybe it works. And I think we need to reverse the order. So like this. And fingers. Oh, yes, it did. Right. So with any luck, we did find the 2 IP addresses of the Cobalt Strike servers. What is the host header of the first Cobalt Strike IP address from the previous question? The first IP address, that's this one, right? So since it's HTTP traffic, let me filter on HTTP traffic, and IP address equals not that one. What was it? The IP address equals 185.106.96.158. Like this. And yeah, for this we are going to follow the HTTP stream. And let's check the host header. And think this is it. This is the host of the first address, first Cobalt Strike address. So let's try OCSP VeriSign. And yes, it is as well. Cool. What is the name? What is the domain name for the first IP address of the Cobalt Strike server? You may use VirusTotal to confirm if it's the Cobalt Strike server. What is the domain name for the first IP address of the Cobalt Strike server? Well, since we already following the stream, we can simply turn on network translation, right? Like this. And then this, the servemeter.live, would be the name. If I'm not mistaken, according to the format, we might be right. Servemeter.live. And yes, we are correct. What is the domain name of the second Cobalt Strike server IP? And again, we may use VirusTotal. We don't need to use VirusTotal. Let's do the same as we did before. We filter on HTTP and we filter on address, address destination equals 185, 125, 204, 174. Let me look at this IP addresses. No, IP address, right? IP address like that. Okay. And well, let me check my exported objects, HTTP again. And we do see a host name coming up a lot. And we can assume this is post-exploitation because this is the stage where the documents.zip is sent. Can we confirm this? Maybe HTTP, what is it? Request, that's a thing, dot method equals post. What is posted? Okay. And we have a few things that are posted to the same destination as we have seen just now. So let's just try this host. I think it's correct. Maldivehost.net, maldivehost.net. And this is correct as well. What are the first 11 characters that the victim host sends out to the malicious domain involved in the post-infection traffic? What are the first 11 characters? Let me just follow this stream as well. And behind the post, we have this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Probably the dash will not count. So this is the first part of it. And submit it. And it's correct as well. How many questions do we have left? Well, 6. We can do this. It's like 10:15. Let me try to finish the next 6 questions within 10 minutes from now. Yeah, well, I want to finish. What was the length for the first packet sent out to the C2 server? The length of the first packet. This is the first packet, right? Isn't it? Let me enlarge the screen a little bit so we have more view. We have a desktop connecting to the destination, destination connecting back to the desktop, and the desktop connecting back to the destination and the desktop. Well, the first packet sent out right. Let me filter it back to HTTP request method. It was post. So we have the complete stream and we have a length of 281. That's the first packet. So 281, and that's correct as well. What was the server header for the malicious domain from the previous question? What was the server header? Okay, let's follow the stream again. So I have a feeling we are jumping back and forth. And then I think this is the server header. Let me try to copy this and paste it in the answer field. And we are doing a great job. It's correct as well. The malware used an API to check for the IP address of the victim's machine. What was the date and time when the DNS query for the IP check domain occurred? So we know DNS traffic is involved here. Let me turn off name resolution for now, so I can see the source. And let's filter on the IP address. And then we use 10.9.23.102. And we want to know DNS. And this should let us see all the DNS traffic by that IP address. And then what was the question? Used an API to check for the IP address of the victim's machine. So maybe we just have to search through these packages and search for API. Might that work? Let me search. I was hoping to search to the packet details. Display filter. Now let me search for a string. And let me search in the packet details. And let's try to search for an API in the packets. A space PI. Okay. Let me search more information. It all looks like the same address. And it did ask me for the date and time when the DNS query for the IP check occurred. Okay. DNS check. Well, let me change my view to this to view the time in UTC, like UTC date. Well, anything works, I guess. Because now we are seeing nanoseconds. I don't know if we need nanoseconds. And we need to find the moment the DNS query. Here we have a DNS packet. Oh, here we have a standard query, API dot. This might be something we need. Yeah, here we have a standard DNS query, and we needed the date and the time, so we cannot copy that. Let's try this one. 2021 09/24/17, and it's 04. And we do not need the nanoseconds, but at least it's correct. 3 more to go. What was the domain in the DNS query from the previous question? Let me check the packet details for that. I think we already have seen it, like here, api.apify.org. api.apify.org. No? Did I make a typo? apify.org. apify.org. Okay. What was the domain in the DNS query from the previous question? Oh, let's use an Y. Still not? Copy the value. And now it does work. Why does it work now? I have no idea. Whatever. At least we are correct. Looks like there was some malicious spam or mail spam activity going on. What was the first mail from address observed in traffic? Mail from. So if it's mail, I think we are talking about the SMTP protocol. Let me check. SMTP traffic. There was some SMTP traffic. Okay. And we will use the search function again. And now we are searching on mail from. And mail from, and we have an mail address. Let's copy the value and try this one. And we have one more to go. The last question, how many packets were observed for SMTP traffic? Okay, how many SMTP packets do we have? We are already filtering on SMTP, and we see in the bottom bar we have 1439 packets displayed. So let me guess there are 1439 SMTP packets. 1439, and congratulations, we have completed the room. That was pretty quick. I was in doubt we could finish it within an hour, but we almost did. Yeah, cool. So we completed the Carnage room from TryHackMe, and while doing so, we have played with Wireshark and analyzed a PCAP file for different kinds of traffic. And I hope at least seeing me puzzle with Wireshark was at least a little bit interesting. But this was all I had for tonight. At least it's night here. So let me thank everybody for watching that's still here with me. Yeah, I don't know if you want something else to say, but I think we are going to wrap it up, right?
Yeah. If there are any questions from the people who are watching, then now is your chance to ask something about the first part. There's not much to ask, I think. But if you have any questions about this Wireshark, then place it in the chat. You have 1 minute, or else we are going to wrap it up.
Yeah. Yeah, I was a little bit in doubt because I haven't seen this box before. I've heard about the box. That at least it was a nice Wireshark box to play, but I was a little bit in doubt that we could finish it. So I'm happy we did. Yeah, 20 questions.
Yeah, it's a nice room.
I wonder if there's a hard Wireshark room.
Yeah, probably.
Yeah, that must be right.
There's one website which focuses on Wireshark.
Oh, nice.
I don't know it out of my head, but T-Shark.
As far as I can see, at least on TryHackMe, there are only medium-sized rooms and easy ones. Oh, right, misguided ghosts. That one is hard. Yeah.
Yeah, but it's more like Docker Escape 2, port knocking.
Yeah. Reverse tunneling might be interesting to do in the next video. But I think we need more than an hour to play this one.
That I know for sure.
Maybe it's a nice thing to for the next time, or maybe sometime in the future, to just play a room together. Like we have more time to play, and maybe we can cover some of the hardest topics out there. I think that would be fun.
Yeah, I think too. Yeah, it's also dependent what the users want.
Yeah, they're quiet at the moment, so maybe we will ask the question again in our Discord channels.
Yeah, that's a nice idea, I think. Yeah, well, yeah, there are no questions so far I can see. So, yeah, I think we are wrapping it up. I want to thank Jarno again for being here, doing the Wireshark part.
It's my honor.
Yeah, as I said, the structured exception handler will be moved to the next TeamUp session next month. So I hope everything will then be ready. I'm thinking about buying an Amazon Web VPS, as then I know for sure nothing will go wrong, as all the power needs to be there at Amazon and not at my computer, so at least it will not crash, I hope. So yeah, again, thank you for watching, and yeah, if you have any questions coming up later tonight, tomorrow, whenever, ask Jarno in his Discord channel, or ask me in my channel, or hit us up on Twitter, LinkedIn, wherever you want, and we can always answer your question. So yeah, have a nice evening, take care, and see you all next month.
Well, again, thank you so much for having me, and I want to wish everybody a great night as well. And well, see you next time.
Take care,
bye, everyone.
Yeah, bye.